Good evening to all. Here we are present to address you all, to invite you all on this auspicious occasion when whole India is celebrating the Mahakumbh, the Heritage Festival of India after a long years, 144, to celebrate the auspiciousness of the Indian heritage on this occasion and on this duration. Again, we are launching our annual function, the promotional event, Sarabhai, space science related lecture series, and today it's the first lecture. We'll listen from Dr. Balveer Singh from the University of Dundee, United Kingdom, Scotland. So it's a precious moment. We are also inviting you all to join us in our Google Meet or in YouTube, and also to subscribe our YouTube channel and like our YouTube channel as well as our Facebook pages, and to attend the most full and meaningful event which has been organized by National Council of Researcher Teacher Scientist India along with National Council of Student Scientist India. Since 2020, both are affiliated to Vipnet Vigyan Prasar, Department of Science and Technology, Government of India, along with DASA India, an organization dedicated to science promotion and popularization. And this is an event since 2020 it is performing with a motto to motivate science-loving students to build up the nation as a scientific one, as well as to find out the students like Dr. Vikram Sarabhai, who wants to be space scientist for future when we are in Vikasit Bharat at 2047. This is a year we are celebrating Amrit Mahotsav also for our independence, and along with that for our Republic Day also. We are celebrating 75th of Republic Day on 26th January. So I invite you all to join our 6th India International Sarabhai Student Scientist Award 2025. It has already been started, and every Sunday between 10 a.m. to 4 p.m. you can attempt the first round of the award competition, that is the e-quiz round to Google form. It was a password protected form. You just log into this form and read this form for its syllabus, for the dates of attempting the quiz, basically which are the Sunday in between 1st January to 23rd February or in between 28th February. And also I would like to invite all of the students to join the concerned WhatsApp group also, so that you can be updated about this award function, your results, as well as our different initiative science popularization. Myself, Anjan Goni, being the National Chairman of National Council of Researcher Teacher Scientist India, and also the Chief Organizing of 6th India International Sarabhai Student Scientist Award 2025. And also due to these platforms and these activities, I has been awarded with the National Award for Science and Technology Communication conferred by the NCSTC, Ministry of Science and Technology, Government of India, and it has been handed over by our Union Minister of Science and Technology, Dr. Jitendra Singh, on 28 February, National Science Day 2023. So it's a privilege to me to invite you all for this event, for this lecture, and for this award competition also. We are just starting our event with a holy lamp lightning. So please bear with us.
सहनो भुनस्तु तेजस्विनावधेतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। हरिः ॐ। संनो मित्रः संवरुणः संनो भवत्वरियमा संनो इन्द्रो बृहस्पतिः संनो विष्णुरुक्रमः। नमो ब्रह्मदेव नमस्ते वायो त्वामेव प्रत्यक्षं ब्रह्मासि त्वामेव प्रत्यक्षं ब्रह्मा वदिष्यामि हृदं वदिष्यामि सत्यं वदिष्यामि तन्मामवतु तद्भक्तारमवतु आवतु माम् आवतु भक्तारम्।
So within a few moments, our guest will be there and will joining by him. Hello, sir. Hello. Sir. हाँ, हाँ सर, हाँ सर, हाँ सर, हाँ सर, हाँ सर.
Yeah, can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Your voice is okay.
So I basically make the laptop and our
No,
sitting chair.
no, sir. No, it's okay, sir.
So
Yes, sir. Please check whether you can share or not. No, we'll introduce you, sir. We'll introduce you. Then you can start. No, it's not. Yes, it is coming, sir. Yes, sir. Yes, sir. Yes, sir. It's coming. Yes, it is coming, sir. Wait, sir.
it's coming.
You just minimize the main screen, sir. Sure, sir. Sure, sir. Yes, it is visible, sir. It is now visible, sir. Yeah, 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 yeah. Yeah.
दोनों लैंग्वेज में या फिर सिर्फ इंग्लिश
Yeah,
में?
दोनों में करिए सर, अच्छा रहेगा सबको, मजा आएगा उनको.
As you can prefer, you people can prefer. क्योंकि विज्ञान हिंदी दोनों चलता है.
Yes, sir.
You
Yes.
have to join other students. I think how much how many people can join?
Approx 100, sir.
Okay, then fine. So
So, sir, you stop. Yes, sir. You just stop the sir.
Start. So I basically, yeah, and after 50 minutes, of my talk, then the question answer will happen. It would be good, I think, because we want to finish around 1 hour 15 minutes
Sure, sir. Sure, sir.
approx.
Sir, you stop sharing so that we can.
So Bainik sir, ये विज्ञान प्रसार में रेगुलर आपके प्लेटफॉर्म
सर हमारा ये
पे ऐसे टॉक्स होते
रहते बेसिकली हम 1 जनवरी से 28 फरवरी ये जो है उसमें ये
आई कैन प्रॉब्लम.
सर आप अपना थोड़ा सा स्क्रीन
No, I am not able to hear you
को थोड़ा सा
your sides. I just stop my screen to share.
yes.
So
Yes.
I'm not able to hear from your side. So
yes sir. Yes sir. Yeah. So sir,
yes.
we want to begin with this, sir. First of all, I would like to introduce you that of Researcher Teacher Scientist India, NCRTS, affiliated
Yes,
to
yes.
Department of Science and Technology, RIPNET, Ministry of Science and Technology, Government of India, as well as we are associated with DASA India, the Science Popular Academy, and for since 2020 we are organizing this event, that is India International Sarabhai Student Scientist Award competition. It's January and February with a first round of e-quiz through Google Forms and other forms, online examinations. And after selection of the students, we implement projects on astronomy. They have to fulfill some experiments on astronomy throughout the India. On 12th August, which is a birth anniversary of Dr. Vikram Sarabhai, with the title of India International Sarabhai Students. One student from Maharashtra got this award, and today he will present with us to introduce you, sir. He is Atharva Khandilkar. I would like to invite Atharva to introduce our guest, Dr. Balveer Singh from University of Dundee, UK, Scotland. So over to Atharva. Atharva Khandilkar. Yes, yes.
Primary research focuses on the observation and numerical simulation of various sun's plasmic processes. Additionally, Dr. Singh outreach programs and has delivered several public, popular, and special scientific talks. He has reviewed international United Kingdom. He is also a lifelong member
Atharva, you have to read the text on Dr. Balveer Singh.
Yeah, so
Yes, sir. Hello.
yes, I'm hearing
Was
you.
my
Yes,
voice
yes, your
audible?
voice is audible, but you have read.
Yeah, it's good. It's good. It's,
Extract given to by you.
Okay, okay. So, we have with us, it's our privilege to invite Dr. Balveer Singh, a postdoctoral
yes.
doctoral from University of Dundee, UK. Now, I would like to invite him to give his start his lecture
About
and to
myself.
bless us. Okay, sir. Thank you, sir.
Yeah. So first, to share. So
Yes, sir. Share. You
yeah,
can share,
it's
sir.
shared.
Yes, it is coming, sir. Yes, it is coming. It is coming, sir. Yes, it has. It has come, sir.
And as well as the grand invitation for the because when we talk about the astronomy and we looking towards our galaxy, towards our sky. So first and big object which whatever we can observe, our parent nearest sun is our so excited knowing directly affected on the earth, not only earth, other planet, other artificial satellites as well as our space. There are several things. Power grid sometimes effect on the. So basically, it called planet like Mars or other planets are called Sun-Mars connection. But there are some limitations on observe the phenomena which affect the sun, which affect the earth by sun. So basically today's talk is I am going to talk of our star, that is sun, and what are the connection to the interplanetary space as well as our earth. So the title of the talk is basically putting this to talk about our star, sun. So in very ancient time when people were people were looked have lots of the object, brighting object, lots of the blinking type of object when you observe in the night sky. So basically the people are interested in what happening in the sky. So the people are not aware initially about any object, about any stars, blinking stars, what happened in the sky. Very the story was started from in the beginning of civilization, when the people are starting the observing the such objects like blinking stars, like other moon, like sun, and other objects. But they stars, what are other scientific thought behind these kind of things. So basically, they don't know much more about the science. They don't know much more about the astronomy. They don't know objects at very fine scale. So, but they interested to know. They know basically the pets, and after few hours, after 12 hours, after 10 hours, after 14 hours, a few hours later, the sun is going to set. So it is basically the pattern when the sun is right, sun is going to set. Normally the sun, moon, in case of moon, moon basically the shows the brightness in the night sky, but in daytime the moon is disappear. So when in night time, it is not a story about the moon only, it is not a story about the sun only. The whole structure of the sky, there are some pattern like stars, group of stars, which is called constellations of star. So that constellations of star is also moving, also showing the pattern. So the started, so actually interested in the pattern, know better about the pattern. So I pattern of the pattern of our sky, day to night, night to day. In the night time, the moon is appeared, and in the daytime, moon is sudden. The sun is going to set. That people, when the civilization is started, and that pattern is actually responsible for the curiosity to know about much more about our universe, much more about the this related to this is captured by myself when I was participated in a conference near Udaipur Solar Observatory in April 2023. So this pattern is about all stars, all objects present in the night sky, like sometimes comets, sometimes asteroids. Us to develop the curiosity and to know about much more about universe. So when we are talking about our galaxy, where we exist, so thought scientifically, so they consider about that we are in the center of the universe. So they know about the universe, जिसको हिंदी में ब्रह्मांड बोलते हैं, है ना? तो they people are basically knowing we are existing in the center of the universe. We are the part of the center of the universe, and whole universe across us. But where we existing in our galaxy, where we existing in our in the universe. So when we started the scientifically to where we exist, so first we look the galaxies. So we are living here, basically these points where my cursor is rounded. So we are not basically from the center of our galaxy. So center of our this is our center of galaxy. So we are basically in the arms of our galaxy Milky Way. This is basically the this is not a direct observed images, because we cannot we are not, because we are inside our galaxy. So when we are inside our galaxy, suppose we are inside one room, so we cannot take the picture of whole room. So this is basically the mosaic image, synthetic image. So taking picture from different parts, and we engaging all the parts and discuss about our galaxy, what are the lifetime, what are the age, what are the other things are. But our Milky Way galaxy is basically the spiral having spiral arms. We are existing in the, so basically in initial days when civilization are started, so people doesn't know about the science behind the sun or science behind any object in universe. So they aware about the pattern. So when the people feels, suppose in the morning the sun is rising, so people basically feel without sun there is no possibility to survive. The sun as a god, because they consider without sun there is no possibility to survive, because when the summer is winter is coming, so people feel some colds, and when in the daytime sun is rising and sun is in the midday, so it appears some hotter, survive on the earth. So and they consider the sun as a god. So not only in not in a single civilization, but all civilization, as well as Babylonian and Sumerian culture. So the Sumerian is name of the sun. The sun is a god, and without sun there is no possibility to human being survive in the earth. So the discussion about the sun was started when the sun is rising and follow the pattern in a day, and not in a day but in a year, because sometimes people about the season. So sometimes after 3 months get the change the seasons, and again after 3 months change the season, rainy season, winter season, and summer seasons. So there are seasonally pattern, as well as the civilization is not started. So that could be very interesting to know much more about the sun, because sun is our nearest star. So we are basically excited to know more about the sun. So when we talk about the sun, so we consider sun as a star. So there are some physical properties of the sun, and there are some physical mechanism, and there are some other plasma processes occur in the star. So normal every star means sun is not a specific star. So basically there are so many stars like sun-like stars are present in the universe. So sun is not a specific type of stars. But why we study the sun, why we're not going to study another star in the universe? Because there are some reasons why we study the sun. Whatever I am going to discuss. So sun is now from a normal average star. So the sun is around 9 billion years, and after 9 billion years sun is converted into a red giant, and end of this stage sun is basically converted into a white dwarf. So I'm not going to talk about how the life cycle of a star is. So we are basically suffering in the middle age. So when any stars are going to birth, or any star is going to die, so people are not much more interested in the middle phase of the sun, because at the time of birth there are several core in the sun, and there are several other processes. So people are not interested much more when a star is suffering in the middle age. People are more interested when any star is going to birth, or any star is going to die. But we are interested in our sun because when we are looking towards universe, other stars in the universe, so we found that the other stars is basically appear teeny object in the universe. So sun is a big edge. So we are very close to the sun as compared to the other stars. So other stars appear only the dot in the sky. When you go out from your home and look towards the sky, so you found that the other stars is basically like a dot point, basically teeny point in the universe. So we whatever that appearing in as a dot like structure in the universe, but we are able to study more especially resolve of the sun. So on the spatial scale we can resolve more on spatially, so we can look towards study the sun. And of course it is our nearest star, so it is a very special star for all of us. So sun is situated in our center of our solar system, not in the center of the galaxy. So we are basically I recall again, so we are basically in the one arm of the galaxy. So sun is basically situated in the center of the galaxy, our solar system, and our solar system has 8 planets and other asteroids and other satellites also. So sun contains 99.9% mass of the solar system at the center, and of course we without sun there is no possibility to living at the surviving on the earth. So it is our parental star. So many cause sun is normal average star, sun is a special star. On the scale we can resolve better on spatial scale as compared to the other stars. So sun is basically our parental star, and it is very this motivation is basically to study the sun. So the question is that sun. So these kind of things are also there, but the one main thing is that you people can consider the sky is a special laboratory. So a special laboratory of what? A special laboratory of the plasma processes, atomic processes, particle. Not make such observatory on the earth, sun-like observatory on the earth or earth. So sun is basically ideal laboratory for plasma. As per these concepts, the sun is basically we cannot make such laboratory on the ground on the earth. So we are able to study the sun using some ground-based observatory as well as the space-based observatory. So observatory is basically the satellites. So when we leave the satellites in space, so we can observe the different things. When we put our satellite on the ground on the earth, so we can observe the different sun. So why we need to study these object, basically the sun, from the space? These animation reactions of the plasma, bunch of the plasma ejected from the sun surface. So it shows basically the ideal laboratory of the plasma. Yes, anybody? Yeah.
No, sir.
Yes. So, have you any questions?
No, sir. We will take the question, all the questions
Okay, then fine.
later on.
So, when we talk about the sun interior, because sun has divided into two parts for studies purpose. Yeah. So, have you My screen is not visible. Okay, so move forward. Yeah. So when we talk about the sun, so when we're looking inside the sun, so we are not able to look inside the sun. So we have a standard physical model to know about what happening of energy generated from the core and as a photons of air to come on the surface of the sun. So millions of the years. So one photon takes the millions of the year to come on the surface of the sun because it's scattered and it's scattered and absorbs, reabsorbs, and re-emission, reabsorbs, re-emission of million times in the in the interior of the sun, that is called radiative zone as well as the convection zone on the surface. But that's photons, the same photons comes from the surface of the sun to the earth is only takes 8 minutes because the speed of light is 3 lakh kilometer per second, and surface to the earth takes around 8 minutes. So the photons takes millions of years from ejected from the core, and it's come up to plasma processes. The student of 11th 12th know better what are the convection of the plasma processes. Hot water in a tub. So basically when you heating the tub, so take the heat from the lower side of any bubbles and go upward direction, upsides, and then when release the temperature, release the heat on the above, and then that pattern is just process. So when we're looking towards the density, temperature, another parameter of the sun, it's various, it varies from the core to the processes are generating the heat energy of in the core of the sun. As the photons comes from the core to the surface, and again surface to the our earth. So when we're talking about the physical property, I'm not going to discuss our first one, mass, and second one is radius. So you can consider the density of the sun. So what are the density of the sun? Mass and radius. So you can compare with our earth mass, and you can compare with our earth radius. So it's huge times, lakh times of mass of the earth. And when we talk about the radius, so it's 109 times radius of the earth. So you people assume the volume of density. But when we look towards and when we compare to other planet, our planet, like the big planet in our solar system, Jupiter, so sun appears like this. So the story of observing the sun before 1600, so people are basically observed by the naked eyes before 1600 because they don't have the telescope, they don't have any observatory, they don't have any the story of observing the sun using the telescope is started from the Galileo Galilei, who is very famous astronomer of the sun. So Galileo during 1613 AD, so Galileo observed the sun by telescope, and these are dark patches. So basically these are the hand-drawn images of the sun. So these dark patches are called, sunspot in, today's time. The Galileo used the word the human beings, and sun is a god, so it is not possible to, pimp us of the sunspot. So basically it matter, of the, south pole and north pole of the sun, because it depends on where they every day Galileo, when wake up in the morning and observe the sunspot using their telescope, so the sunspot at the, so these are the mismatching. So these spots are basically the moving. So Galileo found that first time sun is not a constant, but sun has own routes. The several telescopes, several spacecraft are basically observed the different type of rotations, and different parts of the sun is rotate with differently, means, the equator and pole and other part of the sun is rotate differently. So the story of observing the sun started from Galileo, but the modern days when we are going to space, so sun looks is very different as scope. But today's the modern telescope, there are sun surface. Sun surface is basically the sun's photosphere, where the photons comes from the surface and reach our Earth. So it look like this. So that's the similar sunspot where the Galileo was hand drawn images. The similar sunspot look like this. So you imagine the size of this sunspot is about 10,000 kilometers diameter, which is able to of the Earth. I mean, the size of this big object sunspot. So basically sunspot is made by two region, which is the center region, is basically called the umbra. So basically they have the open magnetic field lines, vertical magnetic field lines, and other this region is called penumbra. So sunspot made by umbra and penumbra both. So umbra is basically darker lower atmosphere to the upper, so they basically lower, and these are penumbra, which is basically hairy like structures, and there are so many things. So I'm not going to detail discuss about the sunspot, how this sunspot is forms and other physical mechanism behind the sunspot, but it is basically compared with the size, compared with the Earth size. So you found that the sunspot is so big as compared to the when we observe ground-based telescopes. Around the sunspot, these are bubbling like structures, जैसे मटर के structure की तरह होता है. So these are basically the bubbling like structure, which is called basically moving feature. So I'm not going to detail discuss about granules. So these are two things. First one is observations taken from the the ground based, and other things is observation taken from the space based. So why we are going to space? The question is that why we are going to space, because when we looking towards going to space, so any spacecraft having 400 crore 500 crore money spent in a spacecraft, then we will looking, because we have already several ground based observatories to observe the sun. Not only the sun, there are so many things can observe from the ground based observatory. But why we are spending 400 500 crore are basically struggling with their life, and they are hungry and they don't have a job. But still, the space agencies, not only the ISRO, but other space agencies, NASA and ESA and Chinese space agency, Japanese space agency also look towards the space, because there are several reasons to go the space. So when we talk about the atmospheric opacity of the sun, of the earth, so basically found that the gamma ray and X-ray and ultraviolet like totally blocked in the upper atmosphere of the earth, because upper atmosphere of the earth absorb the gamma rays and X-rays and ultraviolet. So we are not able to see any object in gamma rays, X-rays, and ultraviolet, spectrum. But we talk about the visuals, so many, opacity is also there, but we can observe in visual light. Basically, visual light is basically 400 to 700 angstrom. 400 to 700, nanometer. We can observe in the visual light, and other things is infrared, which is, totally blocked by the atmosphere, Earth's atmosphere. So there are spectrum of the light. There are, so many wavelength in to observe any object. But so we people can, able to measure any object in the radio wavelength. So when we talk about the radio wavelength, so we can just put on our observatory, our basically telescope on the ground. So we can observe other object using radio wave, ground based radio wave observatory. So other long wavelength radio waves also blocked, so we have only the short wavelength, observatory. So these are the region where we looks towards the space, because the gamma rays, X-rays, and ultraviolet light are blocked, as well as other light are also blocked, except visual and radio. So why we need to do multi wavelength? Sometimes there are several range of the observations, wavelength range of the observations. But why we look towards the multi wavelength? Why you not look only the single wavelength, like white wavelength or radio wavelength or other wavelength? And there are 6 people touches. These 6 people are very small as compared to the big object Earth. Elephant. So these 6 people are basically touches the different part of the elephant. Different situation, they observe the different parts of the elephant. And when we call a conference of these 6 people and present their report, so these people basically report what? So these people report someone who touches the leg. So basically they report these are the trees. Someone they touches the stomach of the elephant, they report this is the wall, this is not elephant. Someone who, so they are differently reports, and all 6 members are not recognize that is the elephant. They basically present there are different parts of the sun, there are different part of the elephant. So the idea touch only one part, so we cannot understand much more about what happening inside, what happened on that object basically. So this example is basically to why the multi-wavelength observation is necessary to observe any object, not only the sun, any object, because that these objects are very big objects. So we cannot observe in a single wavelength, because related to the wavelength. So we cannot observe in a single wavelength to fully understand about any objects. So when we talk about the sun multi-wavelength observation, so we found that when we look towards the visual sun in a visual light, so we can observe the sun is like this. So these dots basically the sun's spot. And when we look towards the look in the other filter, so these same structure are appear like this. So basically these dark as well as the white patches is called polarity of sun. the magnetic field. So dark patches is basically the negative polarity of the sun. And when we observe in the different wavelength, so same structure appear like this. And another wavelength. So we observe different wavelength because when we going from the surface to the inner, upper layer of the sun, so temperature is varies. Not only the temperature, density is also varies from when we moving from photosphere to the upper and the temperature is rising sudden. So this rising of the temperature sudden is called basically the transition region, where the temperature is going to 10,000, 20,000 Kelvin to up to the millions degree Kelvin. So when we get the temperature at the photosphere, the temperature at the chromosphere is basically around 6,000 to 20,000 degree Kelvin. And this is the basically mystery of the sun, why the temperature of the outer region is millions degree Kelvin as compared to the inner region, like photosphere and chromosphere. Because when we're talking about the standard laws of thermodynamics, so we are going away from the source, it means the temperature is going to decay. But in the sun's atmosphere, it is totally opposite, where the standard thermodynamical laws are break basically. So these are mysteries how why the sun's outer region is millions degree Kelvin temperature. So we are trying to do trying to understand what the physical processes behind the sun's atmosphere to the temperature is sudden attain in the millions degree Kelvin in the solar corona. So there are several lines. So basically so you we X-rays and UV continua, calcium second, and different at various wavelengths. So the first space-based satellite launched by the NASA is a SOHO. So that image is basically taken from the solar. So this SOHO mission is basically changed the science of the sun, because when SOHO is launched in space, L1 point basically, and the observations taken from the SOHO, and when the observation taken from the SOHO, the people can understand it's very different way when the people observe in using the ground based observatory. So SOHO basically changed the science of the sunspot when at the photosphere of the sun. So you can imagine this is the corona of the sun, outer layer of the sun, and this is the photosphere of the sun. So these are small dots, these are small patches of the suns, and the same structure appear in the outer atmosphere of the sun. So what is the difference between both? Because this is at higher temperature, millions degree Kelvin temperature, this is basically the 6,000, 7,000 Kelvin temperature. So this is related to the solar activity. So when we talk about the solar activity, means, so we are talking about the active region, quiet region. So active region basically the magnetic field is very high, and sometimes loop like structures are there. So these activity are related to our total radiance of the sun. So when we talking about solar corona, so solar corona appears in a different filter. So different filter correspond the different wavelength, and different wavelength correspond to the different temperature. So you can imagine here the sun's corona appear like this. These darker patches are called basically the filament structures. And sometimes the darker patches is appear as a coronal hole. And these are the bright patches, which is basically called active sun, and these are quiet sun, where the bright patches not appear. So they have different names, different parts of the sun. So atmosphere and what are the physical processes. So the sun's magnetic field is basically generated from the, when the polar magnetic field is converted into the, basically equatorial, but I'm not going to use the detailed word when polar magnetic field is going to twisted in the equatorial magnetic field. So, sun has some rotation. So different parts of the sun rotates with the different velocity. So these vertical magnetic field lines basically is northern and southern magnetic field lines basically the rotates. And when these lines are rotates, so these lines are going to flip. So basically these lines are going to rotate. So these magnetic field lines is also going to rotate. And when these lines are basically converted into the, polar field into the equatorial field, basically is called toroidal to toroidal field. So these north and southern is called, and this, called basically toroidal fields. So when the magnetic field lines, collider magnetic field lines is converted into the toroidal magnetic field lines, is basically responsible for generation of the, sun's spot. So you can see here.
अरे तुम किस दिन बाद फोन कर लिए तो क्या
Yeah.
दिक्कत है?
So you
क्या 9 तारीख को वो आए उनका मंत्री का जो भी है कह दिया तो उन्होंने हमने के लिए आ जाएंगे
so please mute off your mic, because we can get, uh, are you people are interested, you have some अच्छा लग रहा है आप लोगों को? Discuss not in detail.
Yes, sir. Very interesting.
Yeah, thank you.
It's very interesting.
Yeah, thank you. So
ब्यूगल साहब आपका
yeah,
माइक
so आप लोग
off
हिंदी
रखें।
लैंग्वेज प्रेफर करते हो? Yes, okay. Yeah, so you can see here the sun's magnetic field are rotate. So before the, signs of the sun, magnetic field also going to rotate with the, the sun's spot number are increasing. So the maximum number are 150. So sun's spot. So the mechanism is that the sun is rotating and the magnetic field lines are also rotate with the sun's rotation, is cause the sun's spot. So I'm not using so much Hindi words, but I suppose you people can, understand. So when we look sun's spot, so this is basically called the, butterfly diagram. So these are the, poles, and this 0° sine latitude is basically the equator. So this diagram is basically, butterfly diagram. So these rotations of the sun's spot is, about when we talk about the minima to maxima, so it takes 11 years. So minima to maxima means when the sun's spot number is maxima, and when the sun's spot number is minima, it is called, sun's minima. So these sun's minima and maxima periodicity is about, total 22 years cycle, because when we talk about minima to maxima and then maxima to minima, it takes around 20 for one full cycle is 22 years. But the the half cycle is 11 year, where the sun maxima is converted into the sun minima. So these are the maxima minima periodicity of the sun's spot from 1800 80 up to 2025. So we found that sometimes it takes the larger sunspot spot area, larger sunspot area. Sometimes it is very smaller. So it depends on the solar sunspot number and area of the sunspot. So sometimes when the sun is not, when we talk about when sun is active, it means sun is active, it means they have sun have lots of the sunspot, number of sunspot is greater, but sun's minima. So during 1650 to 1700, are less are observed because they have not much facility. Periods. So on the earth, the cold ice war, the cold age are started. And Volga River, so Volga River basically got frozen up to 30 years. So 30 सालों के लिए Volga River क्या हुआ, froze हो गया बिल्कुल. And people are basically several thousand people got died because there are little ice age at that periodicity. So means when the sun's spot number is less, so activity of the sun is less, and basically it's related to the temperature, outer temperature of the sun, and that outer temperature is basically related to the earth's atmosphere. So at that period, which is called Manandar minima, so when Manandar minima is happened, so at that time, though, so on earth the people are facing so much cold weather, and lots of the people, several thousand people get died, and Volga River got frozen up to 30 years. So this is the direct impact of solar minima. Not only the earth, it's also related to the other planet also, like Mercury, like Jupiter, like Saturn also. But we are not able to observe on the surface of the other planet. We are just observe the outer atmosphere of the other planet. I'm not going to detail how to observe other planet. Okay, so when we look towards the long-term study about the sun's minimum, sun's maxima, so we started from 1996. Why we are started from 1996? Because Soho, solar and heat end of 1995, basically the December of 1995 and in 96. So we have regular space-based so 1996, you can see here the sun got the minima. There are less number of activity occurring on the sun. But when time is going on, you can see here in 1999 and 2000, the sun gets the maxima at that time. So means the activity is higher. Means activity is higher means the temperature related to the Earth atmosphere, means the Earth's atmosphere have uh, larger temperature as compared to the earlier days. So when we're moving from 1996 to the coming years, so 2021, 2022, 3, 4, and it takes 1996, and again sun get minima around 2007, 2006, 2008. So basically it's around 11-year cycle, solar cycle, when sun get the minima and its maxima. When you into the maxima, and after 11 year, this is the basically solar cycle throughout the year from observed from the 1996. But before 1996, they have ground-based observations are also there. So people ground the number of sunspot and active regions, and to try to fully understand what happened in the sun for long time. Dynamic means there are some transient events and eruptive events are there, so they have lifetime about minute to days. So when any event occurring on the sun of lifetime having 3 minutes, 4 minutes, or lifetime having 3 days, suppose, so in a 3 days the event are totally going to changed. So how can observe the long periodicity of the sun? So basically one is thinking about the sun when the sun is getting means number of active regions. Okay, so these are chromospheric phenomena. So how can measure the how can observe the chromospheric event? So basically when you block the solar, so when you block by either by artificial natural chronograph, like when the moon is going to block, which is called eclipse. So basically eclipse when happen, so you people can observe the solar corona, outer atmosphere of the sun. So in case of solar chromosphere, when the solar photosphere is blocked by artificial chronograph, prominences, because it's huge mass ejections. So basically these are the photospheric trying to understand how cold material is sustaining in the hot corona, because this is still mystery. People cannot fully understand. So the idea of launching the spacecraft, the idea of launching the space observatory is that there are several phenomena occurring on the sun. So they people basically wants to understand how these cool material and hot material, because sometimes this cool material and hot material people are trying to fully understand. Uh, yeah. So you can also imagine, you can also see there are several related structure, beam-like structure. Beam-like structure means you basically jet. So it is called jet, and it is when larger, smaller, observe also in the different filters. Means different filters associated with the different temperature of the sun, and different temperature is associated with the different wavelength of the sun. So you can imagine this the similar structure which I jet also observed in the multi-wavelength phenomena. So why we need multi-wavelength study of these, observation, because we can fully understand about what happened during these jet are ejected, because sometimes these are the cool plasma. Basically cool plasma is basically, this is the photospheric plasma, around 6,000 7,000 Kelvin temperature. And when we talking about AIA 94, AIA is basically the observations of solar dynamics observatory launched by NASA, and AIA is basically the instrument filters. So basically cool material as well as the hot material both are ejected in a same velocity or in a different velocity. The people are trying to understand. So this is also mysteries why these cool material and hot material, because hot material means they have larger energy, kinetic energy, and cool material means they have smaller, moving with same speed or different speed. If moving with different speed, so why, what are the reason? So basically region. So there are so many things happening in the sun's atmosphere. So this is basically the chromospheric observations of the sun. And another, solar flare, plasma solar, class solar flare, M class solar flare, depending on the magnitude of the energy. So solar flare are sometimes so dangerous. It reaches on the Earth's atmosphere, and sometimes it directly hits the power grid and that. So I will show you one slides in coming. These solar storms are basically harmful for our living lifestyle. So because they have lots of energy. So you can imagine here the flare are occurring. Flare occurring, basically these flares are happen due to the magnetic reconnection. So I'm not going to detail what are the magnetic reconnection. These are directed magnetic lines coming each other and interact to each other, and that process there are huge energy are released as a form of solar flares. So these flares come from the Earth, and several organizations working as communication, they affected our daily life. So another event which is called coronal mass ejections. So basically coronal mass ejections is basically the chunk of plasma solid, liquid gases, and fourth term is plasma. So sun is a ball of plasma. So this plasma is chunk of plasma is ejected from the outer atmosphere of the sun, that is called corona. Smaller, this is very huge, this is very large. So you can compare with the Earth size. So this plasma with the magnetic fields also ejected from the sun's atmosphere and interact with outer atmosphere of the Earth. This is not directly effect. Sometimes it can directly effect on upper atmosphere of the Earth, but it is indirectly effect. It basically having indirectly effect because they have some charged particle protons is also there. So it is indirectly effect, and sometimes it is very harmful for our navigation system, our satellite, and other effects. Of course, these are working as driver of space weather. I'm not talking about Earth is Earth weather. I'm talking about space weather. Okay, so how these CMEs can observe? So block the solar surface by or some नेचुरल सैटेलाइट्स जिसको आप ग्रहण बोलते हो, सन और अर्थ के बीच में मून आ गया है ना. So when sometimes moon is going to block the solar photosphere, so then at that case mass are ejected, chunk of plasma are as a form of coronal mass ejections, and they are very harmful. So these measurements happen using some space-based satellites, and you people can also see these dotted bright spots are basically the other stars in the sky. As you people can guess what is this. This is Saturn planet which have some ring around the pole. So it is CMEs, basically called coronal mass ejections. How these coronal mass ejections happen, how much intense, what are the energy, how much, what are the sometimes get larger velocity around 1000 kilometers, sometimes is 400 kilometers, sometimes gets in between 1000 and 400 kilometers. Each CME can harmful for our navigation or other satellite system. If sun release such mass regularly, so how these suns are maintained in its equilibrium? So there are lots of questions, and people are trying to understand using space-based telescope also. So in this, so you can imagine here when you block the solar photosphere and taking the picture of different year of the sun. So basically these are two lines. So green as well as the red. because people are using spectroscopy lines to so you can find here the iron 10 and iron 14 lines, which is green and red. So when we and these lines are these structure basically when we observe in different lines, and so you can find here these open magnetic field lines. So these green as well as red are not overlap properly. It means they have a, they require we need multi-wavelength observations to the sun. So these pictures are taken in 2006. So you people can see here there are so many helmet like structure where the coronal mass ejections and also charged particles are ejected from the sun's atmosphere. Also you can see here the same in 2008 and 2009 and 2010. So you people can see in 2010 images of the sun when sun is measured in iron line. So you people can see here the more helmet like structure are appears in 2010, not more open magnetic field lines like 2006. It is still mystery why sometimes have open magnetic loop like structure happen. So it's basically related to sometimes the sunspot activity of the sun, but still there are need of the observations perform the computer simulation to simulate the magnetic field of the sun. So you can see here the magnetic field effect is sometimes line where some helmet like structure like for this simulation the people are using some ground based magnetic field data taken either by ground based observatory or space based coronal magnetic field lines. So why, yeah, so question is that, so we are not able to observe the coronal magnetic field. Of course the Aditya L1 is the India's first space based solar observatory have coronal magnetic field lines, strength of coronal magnetic field. So before these missions like Aditya L1 or other, people are trying to magnetic of the sun's surface, and some extrapolations and models are used the coronal magnetic field lines, because without understanding the magnetic field we cannot fully understand about any physical processes like CME, like solar flare, like jets or other any phenomena, because magnetic field is a crucial role of the sun, because sun have no magnetic field. Sun is so boring, cannot spend much time to study the sun, study the sun, because magnetic field is responsible. So in sun atmosphere, magnetic field as well as the plasma both are frozen in field. So this is not the structure of magnetic field. Magnetic field is the both are the frozen. When the we process to fully understand, so we people can observe the solar phenomena. This is called solar wind. So solar wind is basically what? Solar wind is basically the ejection of the charged particle, the mainly the proton. So these protons are ejected from the atmosphere, and we are here. So our earth is here. So you people can imagine how much protons, how much charged particles can affect our earth atmosphere. So this is called miles per second, which is happening on the earth. But these are very high speed plasma, very high speed charged particles. highlight some Parker solar probe, the result taken from the Parker solar probe. So you people can see here the ejected protons. So the ejected, charged particle as a solar wind, how these solar winds are act, and it is interacted to the Earth upper atmosphere as the very beautiful structure which is called auroras. So I'm coming to this point, auroras. I think yeah. So Parker solar probe. So why we discuss about the Parker solar probe? Why we need? Because Parker solar probe is 18 by NASA, and it approached to the sun's atmosphere, and it is very close as compared to the other. So they have each specific, each spacecraft, each observatory, each satellite have specific goals. We cannot measure all the suns, we cannot observe all the sun going only on telescope. So we know of telescope because they have limitations of telescopes. So solar probe have there are 3 to 4 main goals. Trace the flow of energy, basically the charged particles such as solar wind, because the Parker solar probe is approaching much close to the sun, and how these particles are ejected, what are the structure, what are the dynamics, these particles behave with the field, and these particles sometimes accelerate from the pole, sometimes going to study these kind of signs of the sun. So you can see here, this is our sun, and Parker solar probe revolves of 18th. It completed the 18th schedules, 4 schedule, and it have cover basically the 7-year nominal mission duration. So after 7 year, it may be work. I don't know the fully. Yeah. So the charged particle, when the charged particle comes from the sun's atmosphere, so as you can see here, so these charged particles are interacted with the Earth's upper atmosphere. So magnetic field lines are basically the disturbed. So magnetic field lines of the Earth upper atmosphere are disturbed, and the interaction is structure which is called the auroras. So you people can see here the very beautiful structure as a auroras. So auroras basically mainly happening in the at the pole of the magnetic field, larger magnetic field. So they interacted with the larger magnetic field, and sometimes appear these structures. So people can pass by naked eyes also sometimes. Yeah. So this is the computer simulation ejected from the sun, and interacted with the Earth's atmosphere. This is basically the computer generated simulation. So people are doing simulation to fully understand what happened in Earth's upper atmosphere. So these are the happening in the sun, and we need to understand more using some space-based satellites. So we are going to talk about I think there is some problem. Yeah. Yeah. Wait here. Yeah. So I'm going to talk about storms affect us. So suppose, so these are, solar panels and other, bodies of the satellites. So the charged particles come from the sun, basically mainly the protons, and hits on the, the your satellites, which is revolving the space, which are living in the space. Okay, have the in have in lower Earth orbit, and if the charged particle and CME or solar flare hits in the lower Earth orbit, so they have not capable to temperature. So it would happen when we talk about what solar storms may be harmful for the space walk people. So there are astronauts, which is basically solar storms are harmful for other space travelers also. So space travelers have different phenomena can occur due to the charged particles and CMEs and other you know so like solar flares. So when you talk about the physical processes of these phenomena, so these are sometimes may be very harmful. So the yeah, so these are the cluster of our launch satellite also, not our, but our means the NASA and other space agency satellites. You can so many space is fulfilled with with so many satellites. So the question is that where we can put our satellites, where we can put our observatory to better understand, to better observations, take better observation of the sun. Okay, so people are chosen L1. So L1 is basically if you talk about, if you study about two body problem, so there are two body and there are 5 Lagrange five. So in between sun and earth connection, there are 5 Lagrange points are there, where the yeah. So these 5 points basically where we can leave our satellite observe the continuous observation of the sun. So these are potential field lines when you leave our here, we 24 hours observations of the sun. We cannot observe 24 hours using L2 point, which opposite side of the earth and opposite side of the sun. So we have only 3 points to observe the continuous observations of the sun: L1, L4, and L5. But we need to provide L1. The L1 is phenomena are occurring from the sun's atmosphere. So it directly effect on the earth. So when our satellite is here, when we leave our satellite here, Aditya L1 basically, so it observe the phenomena. What happened to us? What happened? What happened as CME lives without any occultation, because we can observe 24/7 from the L1 point. So this is the importance of L1 point. So our satellite leave at L1 point. So hollow orbit, basically the 3D orbit, around the L1 of 8 to 10 kilometers. specific, distance, and you can see here how our satellite is going to launch. So basically, first it's ejected in the lower Earth orbit, and when the speed is going to increase by its starting in the thrust of increasing speed of any satellite our rocket is display our satellite in lower Earth orbit. So this is basically the hollow orbit around the L1 point. This is the hollow orbit around the L1 point of a specific dimension. So the dimension of hollow orbit, like of this hollow orbit intersect alone, and it's released several data for the science. So what is Aditya L1? So I'm going to finish because time is what is Aditya L1? So Aditya L1 is basically the observatory class mission. So we are talking about observatory class mission. It means several payloads. Several payloads means several instruments to observe the different parts. So first, you know, payload is VELC, which is called Visual Emission Line Chronograph, which is basically which is mainly observe the solar corona as well as the magnetic field. So I'm not going to detail talk because it takes 3 to 4 hours on talking on one instrument. Second one is SOOT, that is Solar Ultraviolet Imaging Telescope, which is basically going to study the deep in lower atmosphere of the sun, that is photosphere and chromosphere activity of the sun. And sometimes Helios and Solex, Papa and Aspects and magnetometer are there. So there are two type of payloads are there. First one is the remote sensing. So these four instruments are remote sensing. It means it observes the sun remotely from the L1 point. So measurement means there are some charged particles happening, or there are some charged particle ejected from the sun's atmosphere, and the particle are reaching at L1 point, and that basically these three instruments are measure the physics of this that particles. Aditya L1. So you people can see here the visual emission coronal line chronograph is developed by the Indian Institute of Astrophysics. Yeah, of course I'm going to. And they have lots of the experimental lab, and they have idea to how to perform the instruments. So this across the India, because the different science people are in different research institutes in India. So Indian Institute of Astrophysics basically in Bangalore Astronomy and Astrophysics Ayuka. So Durgesh is leading the Solar Ultraviolet Imaging Telescope SOOT, which is going to study about the activity of photosphere, chromosphere. There are two X-rays, that is called solar low energy X-ray and high energy X-ray. So basically it's measure the observe the X-ray wavelength in 1 to 30 kilo electron volt and 10 to 150 kilo electron volts. It's developed by different lab, that is ISRO Satellite Center and SAC, ISAC and Udaipur Solar Observatory. And the in situ payloads, these are in situ payloads developed by first one is Physical Research Laboratory, which is Aditya Solar Wind Particle Experiment. So basically measure the observe the particles comes from the suns, and plasma analyzer package for Aditya, that is called PAPA. So the PAPA instrument is basically also understand the composition of the layer or not, which among which ions are there, heliums are, hydrogens are, whatever. Basically developed by Leoj and ISAC. ISAC is a part of ISRO satellite center. So the magnetometer is basically to measure the magnitude and nature of interplanetary magnetic field. So the magnetic field play the crucial role. So you people can hear the use of the see how the VLC is going to open their of the sun. So instrument open settle and observe the sun wavelength. So these are other instruments. I'm not going to detail. So VELC is going to observe no instrument have capability to measure such large field of view of the sun, because we have the physics of the suit VELC. So lots of larger field of view, as well as suit instrument is going to observe. So this is sun is behave like uh, black body. So when we plot the total solar irradiance, so this is the total solar irradiance you can find here in between 200 to 400 nanometer. So there the flux is going to change. So suit is going to observe. Suit is very unique instrument, and suit is going to continuous observe the sun's atmosphere between sunset message and other other event happening in the solar photosphere as well as the solar chromosphere. So this is the first observations taken by the suit in different filters, because suit have 11 filter near the ultraviolet range. So in different filters. So the idea of different filter is what? The idea of different filter is different height by the temperature range, specific height. So suit have released lots of the data, and people are continuous working on the science. So these are the open science question on Aditya L1, which will address. So I have already discussed what these instruments can measure the can observe the different phenomena happening on the suns, like VLC is going to measure the solar corona, and going to measure the deep suit is study about the solar atmosphere. So it's all about that. And we are very curious to observe the suns. When I was in Aries, Aryabhatta Institute of Sciences, where postdoc have conducted several workshop for the students, and we are very excited to understand about the suns because I take the lots of time. So thank you so much. Yeah, so questions are welcome. Yes, you can just unmute your mic and you can ask. Sir, we have little bit time.
Also, sir,
Yeah.
so that we can invite all the.
Yeah. Okay. So
So it's a great presentation from Dr. Balveer Singh. We get understand all. We are very much interested about sun, but sir has discussed a lot about from very beginning, from the Soho to Aditya L1. And not only that, sir is told that the main thing, if you are interested to sun, you have to interested with magnetic field also, magnetism also, because this is the main factor and this is the main thing for which all we scientists are doing so many experiments, and it's going on also. It's a beginning, and hopefully it's a beginning for the experiments around the sun, to understand the sun. So I would request the participants to ask your question. Sahida Akhtar, from the account of Sahida Akhtar, please ask your question.
Hindi, if you are comfortable. Yeah, Said, what you want to ask?
Yes.
Thank you, sir, for this information. Good. My
Yeah.
name is Mohammed Ahnaf, and I am studying in fourth grade. The topic is
Ask your question. Hello. Hello. Ask your question. And
thank you, sir.
and now Tahira
So,
Firdaus. Tahira, unmute
Good
yeah,
yourself.
evening,
good
sir.
evening.
Yes, ask your question.
Sir, you had a very good representation.
To join space, basically, as I consider, as I space program, how you can participate in that, participate in the space program. Okay.
Sir, I mean to say that
Sphere. Flying in the major sphere of the Earth, troposphere of the Earth, which is about 10, 20 So when we observe the suns and observe from the space using space-based telescope, so the atmospheric effect certain layers of the Earth's atmosphere. When the sun is rising, it means that effect is appear in the atmosphere. So the due to neglect these effects and take the observership sync, so people are choosing the and is correctly. Okay.
yes, sir. Thank you, sir.
Yeah.
Sir, one
Okay.
question
Thank you.
from
Any other?
yeah, one question is from a student
I
that
think
how
we should complete.
yeah, sure.
Yeah.
This is the last question. How he or she could be join the space program? Yeah,
I
how
not
he or he could be, yeah,
wrong.
how he or she
Yes.
could join the space program.
Yes. Under 11, 12 people when the students are in 11, 12 class 12. So there are several ways to join the space program. First, that is Bachelor of Technology from various IITs or other of BTech. You can join the ISRO and the portal to join every and BTech people are masters, MTech, they also. So they have so if you wish to join as a scientist, if you wish to join as a engineer, so first crack the IITs exams, JEE mains, and take the admission in IITs and experience, then you can join also. So ISRO has ISRO is open all time their portal to join.
Sir, the last question. One
Not ISRO,
last
people are looking
question.
towards
One student
NASA, people are
want.
looking towards European Space Agency, Chinese Space Agency, Japanese Space Agency as well. So there people can join also. Yeah. No, I sorry, I did not so you people are hearing?
Sir, just hello, sir. The last question. The last question. Hello. One student want to know about the relationship of Kumbh Mela. Kumbh Mela, yes, with Kumbh Mela with sun, sir. Yes, sir. Yes, yes, sir. Thank you, sir, for being with us. Yes, sir. Thank you, sir. Sir, at the last, yes, sir. At the last, we have with us Bugle Jain from Kota. He will give the vote of thanks to all of the Bugle Jain with Kota from Kota. He will give the vote of thanks. Due to some Bugle Jain, sir, facing some problem. So thank you, sir, for being with us, and really impressive one. Impressive. We hope, sir, in next any session we will meet again, sir. And with these words, I would like to conclude here. Thank you, sir. Thank you. Thank you for being with us. Uh, Once again, I would like to invite all the students, especially studying in class school level, to join our program, which is going on from 1st January to 28th February. In between every Sunday, we are conducting the first round e-quiz through the form we have distributed here in the scroll, as well as in description also, YouTube description also. We have given the link, so you can use that link and appear in the first round selection for the sixth India International Sarabhai Student Scientist Award 2025, which will be conducted throughout January to July, and during the August 12th, which is the birth anniversary of Vikram Sarabhai, we will confer the final topper five students with this award. So join this award competition, and also to motivate us, please like and share as well as subscribe this channel, so that we can make something new and different in our motto to motivate you to be scientist for future, for new India, for Vikasit Bharat 2024. With these words, I would like to conclude here. Once again, thank you. Jai Hind, Jai Vigyan. Have a nice day.